Ever wondered if we're living inside a black hole? The James Webb Space Telescope might have the answer. Recent observations by JWST reveal that a majority of early galaxies are rotating in the same direction. That's right, out of 263 galaxies, 60% spin clockwise while 40% spin counterclockwise. This is super weird because, according to our current models, there should be an even split. So, what's going on? One theory suggests the universe itself might have been born rotating. Imagine our entire universe inside a black hole, spinning like a cosmic whirlpool. Another idea is that the Doppler shift and the Milky Way's own rotation are messing with our observations. This could mean we need to redo how we measure distances in space, but it doesn't stop there. If these findings hold up, our beloved cosmological models might need a major overhaul. We're talking a complete rewrite of how we understand the universe's origin and evolution. More research is needed, but one thing's for sure, the universe just got a lot more mysterious. Stay curious, space enthusiasts. Black holes are enigmatic objects. They are celestial bodies of immense density and gravitational pull so strong that nothing, not even light, can escape their grasp. This is why we call them black. Their reputation precedes them. They are often portrayed as cosmic vacuum cleaners, relentlessly devouring everything in their path. While it's true that black holes possess immense destructive power, this perspective is incomplete. Could they also be guardians of the galaxy? No, not those guardians! Recent scientific discoveries suggest that these cosmic behemoths might play a more nuanced role in the universe. They may be guardians of life, rather than harbingers of destruction. How can something so powerful be responsible for creating life? The answer lies in the complex interplay between a black hole's incredible energy output and its surrounding environment. This delicate balance can influence the formation of stars and planetary atmospheres in ways we are only beginning to understand. Black holes, despite their dark nature, are far from passive. They are dynamic entities, constantly interacting with their surroundings. As matter spirals into a black hole, it forms a swirling disk of superheated gas called an accretion disk. This process releases tremendous energy, often in the form of powerful jets that blast out from the black hole's poles. These jets, composed of high-energy particles, can travel for thousands of light-years, influencing the interstellar medium. Surprisingly, these powerful jets can trigger star formation. When a jet slams into a cloud of gas and dust, it compresses the material. This compression can kickstart the process of gravitational collapse, leading to the birth of new stars. However, these jets can also be double-edged swords. As the black hole evolves, the direction of the jet can change, heating up the surrounding gas and suppressing star formation. The timing and orientation of these jets are crucial in determining their impact on the surrounding galaxy. Another intriguing aspect of black holes is their role in regulating planetary atmospheres. Active galactic nuclei, or AGN, are supermassive black holes at the centers of galaxies, undergoing a period of intense activity. They emit vast amounts of radiation, including ultraviolet radiation. While UV radiation is generally harmful to life, it can paradoxically contribute to the formation of a protective ozone layer. When UV radiation interacts with oxygen in a planet's atmosphere, it triggers a chemical reaction that produces ozone. This ozone layer acts as a shield, absorbing most of the harmful UV radiation and allowing life to flourish on the planet's surface. This effect is particularly relevant for planets orbiting stars within a certain distance from an AGN. The amount of UV radiation received by a planet depends on its distance from the AGN and the density of stars in the galaxy. The impact of AGN radiation on life depends heavily on the galactic environment. In galaxies like NGC 1277, where stars are densely packed around the central black hole, the intense radiation would likely be lethal to any life-bearing planets. However, in galaxies like our own Milky Way, where stars are more spread out, the radiation levels would be lower, potentially allowing for the formation of ozone layers and the development of life. Computer simulations have been instrumental in understanding these complex interactions. By modeling the effects of AGN radiation on planetary atmospheres with varying compositions and distances from the galactic center, scientists can identify galactic environments that might be conducive to life. These simulations suggest that certain low-density environments, where galaxies merged in the distant past, might be ideal for life due to the presence of black holes that promote star formation without the later, potentially harmful jet activity. The study of black holes is a journey into the heart of cosmic mysteries. It challenges our preconceived notions and reveals the intricate web of connections that govern the cosmos. As we delve deeper into the nature of these enigmatic objects, we begin to appreciate their multifaceted roles, not just as destroyers, but also as potential creators and guardians of life in the universe. If you think black holes are just galactic garbage disposals, think again. They might be the key to understanding time itself. Let's dive into the radical theory that's shaking up the cosmos. Recent research suggests that black holes could transition into white holes, spewing out matter, energy, and maybe even time, reversing it. Imagine this. Instead of a singularity where the laws of physics break down, we have quantum fluctuations at the core. This transition could mean that instead of being swallowed forever, everything inside a black hole might eventually get spit out by a white hole. Researchers from the University of Sheffield and Complutense University of Madrid are using a version of Einstein's theory called unimodular gravity to explore this mind-bending concept. While it's highly theoretical and remains unproven, it offers a tantalizing glimpse into how black holes might not be the dead ends we once thought. So, could black holes be the universe's ultimate recycling centers? Only time and more research will tell. This is why you need to know about the black hole next door. Meet the Large Magellanic Cloud, our galactic neighbor. Inside, astronomers have found a black hole 600,000 times the mass of our Sun. The evidence? Hypervelocity stars zooming away at millions of miles per hour like cosmic escape artists. Black holes are like invisible space vacuums with gravity so intense not even light can escape. They're born when massive stars collapse under their own weight. The LMC black hole is a baby compared to the Milky Way's, which is 4 million times the mass of our Sun. Feeling worried? No need. This black hole is too far to affect Earth. But if you got too close, watch out for spaghettification. You'd be stretched and squeezed until, well, let's just say you wouldn't survive. So, our galactic neighbor has a monster black hole, but don't lose sleep over it. Instead, marvel at the wonders of the universe. Curious minds, keep exploring.
Black holes. Just the name evokes mystery. Imagine a place where gravity is king, so strong that nothing, not even light, can escape. These cosmic monsters lurk in the darkness of space. They are remnants of collapsed stars. Black holes challenge our understanding of the universe. They push the boundaries of physics as we know it. What happens inside these enigmatic objects? It remains one of the greatest unsolved mysteries of our time. Scientists have long pondered the secrets hidden within the cosmic abyss. Could information be trapped inside? Could we ever retrieve it? These questions lead us down a path of mind-bending possibilities. Now, let's add another layer to this cosmic puzzle: quantum mechanics. This branch of physics governs the microscopic world. It's a realm of strange and counterintuitive rules. One such rule is quantum entanglement. Imagine two particles linked together in a mysterious way. No matter how far apart they share a connection. Change one, and the other changes instantly. Spooky, right? And now, imagine using this connection to listen in on a quantum conversation. That's quantum eavesdropping. It's like intercepting a secret message encoded in the fabric of reality itself. Imagine two intrepid explorers, Alice and Bob. They venture close to a black hole. Alice, feeling daring, crosses the event horizon. Let's assume for this thought experiment she could somehow survive. This is the point of no return, where gravity reigns supreme. Bob watches from a safe distance, his heart pounding. Alice, trapped inside, can no longer send messages back. But what if she could use quantum entanglement to communicate? What if she could encode information onto a particle and send it back out? This is where the thought experiment gets really interesting. Could Bob, by observing entangled particles, glean information about Alice's fate inside the black hole. Here's where space-time comes into play. It's not just an empty stage. It's an active player in the quantum world. The immense gravity of the black hole warps space-time. This warping, according to recent theories, could create a bridge between Alice and Bob. A bridge built from quantum entanglement. Information might be able to leak out, encoded in the subtle correlations between particles. Quantum eavesdropping from inside a black hole remains a theoretical concept, but it highlights the deep connections between gravity, quantum mechanics, and information. It's a tantalizing glimpse into the universe's deepest secrets, waiting to be unlocked. Our galaxy, the Milky Way, is a vast and mysterious place. Swirling with stars, gas, and dust, it holds secrets waiting to be uncovered. At its heart lies a supermassive black hole, a cosmic monster known as Sagittarius A. But what if Sagittarius A wasn't always alone? What if, until recently, it had a companion, a second black hole shaping the destiny of stars? The idea of a second black hole at the Milky Way's center may seem like science fiction. However, recent discoveries about hypervelocity stars, those flung from the galactic center at incredible speeds, suggest a more complex and intriguing past. These stars, traveling thousands of miles per second, hold clues to the hidden history of our galaxy. Their very existence and their peculiar behavior hint at a time when two black holes danced around each other, locked in a gravitational waltz. Hypervelocity stars are intriguing objects. They are the fastest stars in our galaxy, some moving fast enough to escape the Milky Way's gravitational pull entirely. Their origin, long a puzzle, pointed to a powerful slingshot effect, launching them from the galactic center. The immense gravity of Sagittarius A seemed the likely culprit, tearing apart binary star systems and flinging one star outward at tremendous speed. However, something didn't quite add up. The observed speeds of these hypervelocity stars were lower than expected. If Sagittarius A were the sole engine behind their acceleration, they should be moving even faster. Furthermore, the binary partners of these ejected stars were missing from the galactic center. Where had they gone? These inconsistencies suggested that a crucial piece of the puzzle was missing. To explain the perplexing behavior of hypervelocity stars, astronomers proposed a bold theory: the existence of a second, smaller black hole, dubbed the Goalkeeper, that once orbited Sagittarius A. This second black hole, significantly less massive than Sagittarius A, but still a gravitational heavyweight, would have dramatically altered the dynamics of the galactic center. Imagine the Goalkeeper black hole as a cosmic shepherd, its gravity influencing the orbits of stars near Sagittarius A. This gravitational influence would have prevented stars from getting too close to Sagittarius A, thus limiting the speeds they could achieve when ejected. This explains the lower than expected velocities of hypervelocity stars. The theory of a second black hole, while compelling, requires evidence. Remarkably, simulations incorporating a Goalkeeper black hole accurately predict the observed velocities and distributions of hypervelocity stars in the galactic halo. The missing binary partners also fall into place, captured by the Goalkeeper black hole during the ejection process. The implications of this theory are profound. If confirmed, It would rewrite our understanding of the Milky Way's history, painting a picture of a more dynamic and complex galactic center. Furthermore, it would provide crucial insights into the formation and evolution of galaxies, the behavior of black holes, and the extreme environments found at the hearts of galaxies. The universe was young. Chaos reigned. Stars were bursting into existence, their fiery births illuminating the vast expanse of space. It was a time of immense energy and transformation. From the swirling chaos, galaxies began to emerge, vast islands of stars, gas, and dust. These galaxies were not the majestic spirals we see today. They were young and dynamic, still coalescing from the primordial soup. Collisions were commonplace. These titanic clashes reshaped these young galaxies, forging the universe we know today. Yet, hidden amidst this cosmic ballet, a monster lurked. A giant, 1 billion times heavier than our own sun, was growing in the shadows. This was no ordinary celestial body. It was a black hole, an object so dense, with gravity so strong, that not even light could escape its grasp. This supermassive black hole, a cosmic Leviathan, resided in the heart of a young, dust-shrouded galaxy. It feasted on the surrounding gas and dust. As material spiraled into its maw, it heated up, emitting a blinding torrent of energy. This energy, however, was invisible to our eyes. It was shrouded, hidden from view by a thick veil of cosmic dust. For eons, this monster remained concealed, its presence unknown to the universe at large. It continued to grow, fueled by the cosmic feast. Its influence, however, extended far beyond its immediate surroundings. The black hole's powerful gravity sculpted the galaxy around it. It influenced the formation of stars, the flow of gas, and the very fabric of space-time itself. But to us, it remained a ghost, a whisper of something extraordinary hidden in the depths of space. Observing objects so distant in the universe is a daunting task. The light from these ancient objects has traveled for an incredibly long time to reach us. It is faint and often obscured by intervening gas and dust. Seeing into the heart of a dust-shrouded galaxy from the early universe seemed almost impossible. But astronomers had a new tool at their disposal, the Atacama Large Millimeter Submillimeter Array, or ALMA. This revolutionary telescope, located high in the Chilean Andes, is designed to detect the faint radio waves emitted by cold dust and gas. These radio waves can penetrate the cosmic veil that obscures visible light. ALMA provided a new window into the universe, allowing us to peer into regions that were previously hidden from view. It was with ALMA that astronomers finally detected the faint signature of this hidden giant. The discovery sent ripples through the astronomical community. It wasn't just the detection of a single monstrous black hole that was so remarkable. It was the realization that many more such objects could be lurking, hidden from our view by cosmic dust. This discovery opened up a new avenue for studying the early universe. By studying these hidden giants, we can learn about the conditions that prevailed in the early universe. We can gain insights into the formation and evolution of galaxies, and we can begin to unravel the mysteries of these enigmatic objects that lie at the very heart of our understanding of the cosmos. The universe is full of surprises. It is a place of wonder, beauty, and endless possibilities. And as we continue to explore, we are sure to uncover even more secrets that have been hidden for ages. The story of this hidden giant is just one chapter in the grand narrative of the cosmos. There are many more chapters yet to be written.